I've been working for 4 years as a postdoctoral researcher in a project that is the RESTOV registry of acute ischemic stroke clots. And this is a big registry that was born from the collaboration of our university in Galway and 4 international stroke centers. And we aim to characterize the histopathologic features of clots extracted by mechanical thrombectomy from more than 1,000 patients. So we put a lot of effort also on the discovery part, which was very important to us because we wanted to find novel components for stroke etiology, for example. And this is how the proteomic work was born. Basically, we started from paraffin-embedded clots, and this was already, let's say, the critical step, because most of the time proteomic study use fresh frozen material because it's easier to handle and it's easier to extract the proteins. We had to use paraffin-embedded samples because we got these kind of samples from the international stroke centers which we collaborate with. So it was a critical step to do the paraffinization, and then from there, the protein extraction, then the purification, and finally the injection in the liquid chromatographer. Then we did the bioinformatic analysis, and what we found out, we found out 14 differentially expressed protein between cardioembolic and LAA clots. Specifically, 4 of them were most abundant in LAA clots, and the other 10 were most abundant in cardioembolic clots. About the pathway of this protein, so where, the biological pathway, so we found out that both LAA and cardioembolic clots had proteins that were involved in the ER stress, specifically the UPS and the UPR, so the ubiquitin-proteasome system and the unfolded protein response following ER stress. And in addition, cardioembolic clots were also contained proteins that were related at different level to platelet function and structure. Of course, this was an untargeted approach, so absolutely first step explorative approach. So we didn't know we didn't know what to look at, So we just explored thrombus proteome, and so we found these 14 proteins, and then the next step would be to do a targeted approach, mostly using immunohistochemistry, and to see, for example, with the bigger number of clots, if some of the results that we got from the proteomic analysis are confirmed. And then in the future, if some of these, validation study is successful, my ambition will be to use some of these biomarkers in a rapid test diagnosis, for a diagnosis, and possibly using blood, directly to the patients, because now we are using clots, and of course, it's interesting for research, but to be useful for diagnosis purposes, we need to use that to find the biomarker in, directly in a biological fluid of the patients in a way that we can actually diagnose its pathology, and in this case, stroke etiology, hopefully.